Today we are going to simplify algebraic expressions. First, let's look at identifying terms and like terms. Identifying the terms and like terms in the expression 8x minus 4 plus 6 minus x. Notice in this expression here, there are 4 terms. 8x is a term, negative 4 is a term, positive 6 is a term, and negative x is a term. They are separated by either plus or minus signs. Now we're going to look at that same expression and we're going to identify the like terms. Since 8x and x, or negative x I should say, both have an x in them, they are called like terms. And then the other pair of like terms are our constants, negative 4 and positive 6. Now, if we go back and look at negative x, always understand that even if it's not written in front of a variable, there is always the number 1. So there is 1x in front of there. You can always put a 1 in front of that x. So that's really a negative 1x. Okay, again, parts of an algebraic expression are called terms. So parts of an algebraic expression are called terms. And in order to simplify algebraic expressions, we combine like terms. Like terms are the terms that have the same variables raised to the same exponent. So again, like terms are terms that have the same variable raised to the same exponent. Constant terms are also like terms. Again, constant terms are just plain old numbers. So when you see the word constant, we're looking for a plain old number. These are numbers without variables. So I'm going to write numbers there. If we look at the first example, simplifying an algebraic expression, the one that is done for us, notice they have a negative 2, and then next to the negative 2 they have parentheses, and they have something inside the parentheses. What you need to do here is you need to take the negative 2 and you need to multiply it by everything you see inside the parentheses. That would be your first step, is to get rid of those parentheses. So they did negative 2 times g, and they did negative 2 times positive 4. Notice they wrote that over here. And they just rewrote the plus 7g. Then they simplified it. What's negative 2 times g? Negative 2g. What's negative 2 times positive 4? A negative 8 plus 7g. Next, I notice that there are 2g terms. There's a negative 2g and a positive 7g. Now, I wouldn't do this next step here. I would go straight to this next step. If you combine negative 2g and positive 7g, you get positive 5g. Now, there is nothing you can combine the negative 8 with, so I just write minus 8. And now it is simplified. Example 1. I see 12g plus a positive 4 plus, or adding a negative 5g. So I decided to highlight the like terms. I notice 12g and negative 5g are like each other. So I can combine them. 12g minus 5g is 7g. And then I can't combine positive 4 with anything, so I just write plus 4. You cannot add these together. Think of it as if you have 7 goats and you have $4. You can't say you have 11 goats. And you can't say you have $11. You have 7 goats and you have $4. This is as simple as you can make this expression. Let's go on to the next one. Again, I'm going to start out by highlighting my like terms. I see that there is a positive 8 right here. Are there any other plain old numbers without variables? Yes, positive 6.2. Next, I'm noticing that there is a positive 4a. And I'm noticing that there is a negative 9a. So those are my pairs of like terms. Now I'm going to start with, I could start with the a's or with the numbers. Since the 8 came first, I'm going to start with the 8. What is 8 combined with 6.2? 14.2. What is a positive 4a and a negative 9a? That would be negative 5a. And again, that's as simple as we can make it. We cannot subtract the 5a from the 14.2. Again, think of it as if you have $14.20 and you need to take away 5 apples. Well, you can't do that. You can't take apples away from money. Next, we're going to look at example 3. Example 3 is going to involve the distributive property, I'm noticing. Because I see parentheses and a number out in front, I'm going to start by multiplying 3 by 5, b, and I get 15b. And then I'm going to multiply 3 by positive 2, and I get positive 6. And then I'm just going to write minus 4. Now I'm going to do what I did before. Hopefully that looks like a 6, not a b. Looks more like a b to me. Let me erase. Let me fix this so it looks more like a 6, I'm hoping. I don't like when they put b's and numbers that look like letters in the problem. Now we'll go on and I'll highlight my like terms. I'm noticing that there is no other b term, so I'm just going to highlight that in yellow. Then I notice that my positive 6 and my negative 4 are like each other, so I'm going to highlight them. Now when I simplify this, I cannot combine 15b with anything, so I'm just going to write it. A positive 6 minus 4 is positive 2. And that's, again, as simple as I can combine that. You can't take 15 bananas and add it to $2. You can't say that now you have 17 bananas. Lastly, let's look at the word problem. Write an expression in simplest form that represents the perimeter of the polygon. Remember, in order to find perimeter, we add up all the sides. I notice 2 of the sides have an x in them. I see a 3x and I see an x. I also notice the other 2 sides have m's in them. I see a 6m and a 5m. And we can only combine the terms that have the same letters in them. So let's say I'm going to start with, I like to start in alphabetical order, so I'm going to start with the m's. What is 5m plus 6m? Oh, that's 11m. Plus, what is 3x plus x? Well, if you take 3x and you add an x to it, you end up with 4x. And again, that is as simple as I can make it. Because the variables are different, I can do no more.